Hello class, today we're going to talk about finding the limits of piecewise functions and absolute functions. So piecewise functions, we have to recall what they are. They're a function that's composed of more than one function depending on where you are on the x-axis. So for instance here, when x is greater than or equal to 1, our function is 3 minus x. However, when we go to the left of that, when x is less than 1, our function is 2x minus 3. So you might be wondering, well, how do we find the limit? Well, notice that in these kind of questions, well, specifically these kind of questions, we'll be looking at the limit from where they meet, right? The limit as x approaches 1, well, that is where these functions meet each other at x equals 1. So you might be wondering, well, how do we find the limit? So what we want to do is we want to find the limit coming in from the left and find the limit coming in from the right and see if those two limits agree with each other. If they agree with each other, we have a limit. If they don't agree with each other, meaning if the numbers are different from one another, then the limit does not exist at that point. And it doesn't matter if you do the right-hand side or left-hand side first. It just really doesn't. So let's start with the right-hand side. Now I know this is the top one is the right-hand side because x is greater than or equal to 1. We think of numbers greater than or equal to 1, like 2, 3, 4. Those are to the right of this function. So we have to recall how we write it. So the right, we want to write it as the limit as x approaches 1, the little plus up there. Remember, that means we're approaching it from the right, while minus means we're approaching it from the left. So let's see here. The limit as x approaches 1 from the right of, and this is our function from the right, 3 minus x. Well, this is an easy one. We can actually just plug this in, can't we? We're not worried about the denominator being 0, or we don't have any square roots or anything. So let's just plug in 1 and see what we get. 3 minus 1 equals 2. Now I want to do the exact same side with the left hand, on the left-hand side, and see if we still get 2. So let's go ahead and do that. So the limit as x approaches 1 from the left, that's 1 minus, and our function we're going to use is the 2x minus 3. That's kind of a funny looking 2, but that's a 2. Well, again, we can just plug this in, so let's plug in 1. So we get 2 times 1 minus 3, which is just 2 minus 3, right? And we get, well, 2 minus 3, we get negative 1. Now, because these two don't agree, say 2 does not equal negative 1, the limit does not exist. And that's how you do piecewise functions, limits at piecewise functions. Let's do one more just to kind of drill the point in here. These kind of take some paper or some space on your paper, so I'll get a new one. So the limit as x approaches 1 of f of x equals 2x when x is greater than or equal to 1, 4 when x is equal to 1, and 3x minus 1 when x is less than 1. So here notice that we have 3 different functions here. When x is greater than or I goofed. This shouldn't be x is greater than or equal. It should just be x is greater than. Oops. When x is greater than 1, our function is 2x. When x is equal to 1, it's 4. When x is less than 1, our function is 3x minus 1. So here we still want to take the limit as we approach from the left and approach from the right and see what we get. And again, it doesn't matter if you do left first or right first. It doesn't matter. So let's start with the right. Now, which one is the right function? It looks like it's going to be the 2x because we were talking about x as being greater than 1. So from the right, let's see, we have the limit as x approaches 1 from the right is equal to 2x. Well, again, we can just plug this in. This is not that bad. So we have 2 times 1, which is just 2. Let's see if the right hand agrees. Or sorry, let's see if the left hand agrees. So the limit as x approaches 1 from the left, we're going to be using this function. Not this one, because the 4 is when it's equal. We're talking about as it approaches from the left. So 3x minus 1, well, again, we'll plug in 1, because we can do that here, which gives us 3 minus 1, which is 2. Now look here. You might notice, well, these two agree, right? 2 equals 2. But you might be wondering, well, if we're looking for the limit as x approaches 1, we have the actual value when x is equal to 1, and that's 4. That doesn't matter. Because remember, the limits are describing the function as it approaches a certain value, not when it is a certain value, when it approaches the certain value. So even though we know the value when x is equal to 1 here, I want to know what the limit is, what's happening as we approach from the right and as we approach from the left. So the limit is 2. Yep. Okay. So that's piecewise functions. Let's talk about absolute value functions. Oh, dropped my pen. Okay. Okay. So absolute value functions. Let's say that we have something like this. The limit as x approaches 2 of the absolute value of x minus 2. Well, let's think about what an absolute value is. I'm going to talk about it right off to the side here. Let's think about this function. If you were to graph this function, to put it most simply, if you were to graph this function, f of x equals the absolute value of x, and you may recall this, hopefully you do, that our function would look something like this. Well, notice that there's a sharp edge here. It's not a curve. It's a, in this case, a 90-degree angle here that it makes. So with absolute value functions, we actually can describe them as a piecewise function. In this case, that's what we'll want to do, because we want to describe what's happening here and what's happening here. Now, to describe this one, say the absolute value of x, when x is greater than or equal to 0, which is this part, our function is just x. However, when our function is less than 0, our function is going down, it's negative x. So let's start thinking about absolute value functions as piecewise functions as well. Okay? So let's go back here. Now, I want to describe this piecewise function as this absolute value function as a piecewise function. So I'm just going to kind of write this out. So I know that when x is greater than or equal to some number, and in this case it's going to be 2. Because 2, if I plug it in, it'll give me 0. Okay? So we kind of have to shift it over a little bit, okay? So if you ever see like x minus something, that something is just going to be our division, not division value, but the value where they meet, okay? So when x is greater than or equal to 2, our function is just going to be x minus 2. However, when x is less than 2, it's going to be the negative version of that, just like how it is up here. Whatever was on the inside was our x, or whatever was on the inside is the greater than value. But the less than, our value, is the negative version of that. So this is going to be negative x minus 2. Okay? So now that we have it just written as just like our piecewise function, well, it is a piecewise function. Oh, I forgot my equal sign. As our piecewise function, we'll do exactly what we did with the piecewise function, see if they agree. If they agree, there's a limit there, and if they don't agree, the limit does not exist at that point. So let's see here. Starting with the right side, the limit as x approaches, what, 2 from the right, we're going to use this function, the x minus 2, and again, we can just plug it in, so it's not that bad, is equal to, just plug in 2 minus 2, we get 0. Awesome. Now let's do from the left-hand side. So the limit as x approaches 2 from the negative side, it's going to be negative x minus 2. That is this function when x is less than 2. So, again, we can just plug in our 2. We have negative 2 minus 2 equals negative 0, or just 0. So in this case, notice that they agree with each other. So 0 is equal to 0. Limit as x approaches 2 is 0. Okay? Now, sometimes we'll have to use kind of some fancier algebra with these, both with the piecewise function and with the absolute value function. So don't forget everything that we've learned up until this point. Okay? Let's take another look at, or let's take a look at another example in which that would be the case here. Well, not just yet. I'll save that for the third example. But let's just focus on this one and see what we get here. So now let's say that I want the limit as x approaches 3 of the absolute value of x minus 3 divided by x minus 3. So now we have an absolute value function that's embedded within another function. So my advice to you is first just focus on the absolute value function and let's define it as a piecewise function again, okay? So the absolute value of x minus 3 is equal to, let's see, well, I know the positive version is going to be x minus 3, and that's when x is greater than or equal to what? Well, what number can we plug in to make this 0? Positive 3, right? And then our negative version, when x is less than 3, it's going to be a negative x minus 3. Okay? So now that we've defined it piecewise, let's go ahead, take the left and right, and we're just going to plug our whatever function we're using right in for this. So, start from the right. The limit as x approaches 3 from the right is going to be x minus 3 divided by x minus 3. See how I just plugged in the function that we're using in for x minus 3, and I got x minus 3 over x minus 3. Well, let's think about this. If we plug in 3 here, that's not going to do any good for us because it'd be 0 over 0. But what do we know about something that's divided by itself? Well, anything divided by itself is always 1. So x minus 3 divided by x minus 3 is just 1. So that's our value there, the limit as x approaches 3 from the right. Now let's talk about the left. So the limit as x approaches 3 from the left, we're going to use this function now instead of, or in place of the absolute value of x minus 3. So we have negative x minus 3 divided by x minus 3. Well, look what happens here. Anything divided by itself is 1. We have this negative right here, so the answer here is negative 1. Well, you might notice left-hand side and right-hand side don't agree. 1 does not equal negative 1, so the limit does not exist, or we can just say D in E. Limit does not exist. Okay? Now, one last example, and let's see here. this is one where we might need to use a little algebra. Well, we will need to use a little algebraic trick here. So limit as x approaches 3 of x squared minus 9 divided by the absolute value of x minus 3. So again, let's go ahead and define the absolute value of x minus 3 as a piecewise. So I know that when x is greater than or equal to 3, remember the value that I plug in to make this 0, our function is just going to be what's written there. However, we have the negative version of that function when x is then less than 3. Okay? So now, let's go ahead and find the right side here. So the limit as x approaches 3 from the right, well, I'm just going to plug in this right-hand one in for the absolute value of x minus 3. So we have x squared minus 9 divided by x minus 3. And you might notice, well, now let's try plugging it in. We can't plug it in because we get a 0 on the bottom. In fact, we get 0 over 0. But this on the top should start looking familiar to you. This is a difference of squares. We have a square subtracting, or we have a square subtracted from another square. So remember this idea that, I'm just going to write this over here, a squared minus b squared can be written as a plus b times a minus b. We can write it just, that's an a, just like that. So let's go ahead and rewrite this. So this is the limit as x approaches 3 from the right of, this is going to be the square root of each, which is going to be x and 3. So it's going to be x plus 3 times x minus 3 over x minus 3. And then now you can see, this should be looking pretty obvious now. This cancels. So we're left with the limit as x approaches 3 from the right of x plus 3. And now we can go ahead and plug in that 3. So let's see, 3 plus 3 is just going to give us 6. Now let's do the same thing from the left-hand side. So the limit as x approaches 3 from the left of x squared minus 9 over, now we're using this function, negative x minus 3. And again, we see that this is the difference of squares still, so let's go ahead and just write that as factors. This is the limit. X approaches 3 from the right. X plus 3. X minus 3 over negative times x minus 3. And again, we can see this cancels. But look what we're left with. We're left with a negative here. So remember, a negative can either go on top or bottom. It doesn't matter. So I'm just going to rewrite this as the limit as x approaches 3 from the right of just negative x plus 3. Okay. Hopefully you guys are okay with me doing that. So now I can plug it in. I get negative 3 plus 3, which is negative 6. Now, these, they do not agree with each other, right? 6 does not equal negative 6. So therefore, the limit does not exist. So that's all I have for you all today. That is finding limits of piecewise functions and absolute value functions. Let me know if you have any questions, and have a good day.